For this lab, we're going to be using common, everyday, ordinary yeast. And you can see a picture of it here. It has these little buds coming off. So the yeast is alive, taking in oxygen, giving off carbon dioxide. And since it is alive, taking in oxygen and carbon dioxide, it is perfect for this lab about cellular respiration.
Keep it low key, keep it softly spoken, with no strings tying you to me.
It's going to be on cellular respiration. Here's what we'll be needing. We need an Erlenmeyer flask or a large bottle. And I've talked to you in class about this bottle. This is a really nice bottle, and you'll notice it's taller, and the lid at the top, open at the top, is not as large as the flask. So it's going to make a better glass vial or a flask to use instead of the larger flask. We're going to need balloons. It's always fun when you have balloons in a lab. We got a little bit of tape. Over here we have our electronic scale. We're going to be using that. Behind me here we have the water heating up on a hot pad, and we got some good old sugar here, and we've got some yeast, good old common yeast that you find in the grocery store that you use to make bread with. Okay, so first thing we have to do for our lab, we have our electronic scale here, and we're going to turn it on, and you're going to notice we got all these numbers right here, and then it goes to -4, 3, 2, 1. What it's doing, it's calibrating the scale, so it reads 0, 0, 0. This scale is pretty accurate. If we just go like this with our hand, it causes the numbers to fluctuate. So when we work around the electronic scale, we don't want to have a lot of movement because it can throw off our weight that we have. We're going to place this little tray on here, and you'll notice it weighs 2.34 grams. Okay, we're going to zero that out, or push the tare button, T-A-R-E button, and it's going to cause this little tray to become part of the scale, so it doesn't weigh anything at this point. It's calibrated with that little tray on it. Now we need that because we need 20 grams of sugar, just regular old house sugar here, okay, that we grow in the fields around here, in the sugar beet fields. We're just going to take the sugar, we're just going to pour it in here. Now we need 20 grams. It doesn't have to be exact, but I want you to be exact when you measure it, because you need to learn how to use the scale and how the scale works. So I want you to try to get it exact when you do it. So we got 16, 17, 18, 27 grams. Went over a little bit. That's why I got the little spoon here, a little scoop. And take some off. Keep putting it back in our thing here. Now we're down to 21.6. Okay, now just a little bit more off. 20.34, 36. Ooh, just a tiny little bit more off. Okay, exactly 20 grams. Okay, that's what we want, 20 grams of sugar. Now the instructions say also to weigh our balloons. We're going to take our balloon, we're going to zero our scale, or push the tare button. So make our scale go 0. We're going to put our balloon on there. We're going to weigh it. The instructions don't say this. We also need to weigh some tape. Now this is going to be a little tricky here, but we're going to take our piece of tape that we have, and we're just going to put it here with the balloon. And we'll get it off in just a second here. Okay, come on, let go of me. There we go. Now we need to write that down. It weighs 3.17 grams. Next thing on our instructions is we're going to pour our water into the bottle here. I think that's going to be a little bit too much. We're going to take some. We're going to take 100 milliliters out of there. Okay, so we have approximately 200 milliliters of water in our bottle here. You'll see why in just a minute, why we did that. All right, we're going to take our little tray here, and we're going to pour our sugar in. Just going to stir it up. Okay, it's kind of like we're making hummingbird feed, all right? Then we're going to take our yeast and we're going to put it in. We need to talk about what yeast is in a minute. What's inside this little packet? You use it to make bread with. And so why do you use it for bread? For making bread? Try to get it all in there. Okay. We use it for making bread, and you stir it up a little bit. We use it for making bread because it makes bubbles. It makes the bread have bubbles in it. So there's our bottle. Next thing on our to-do list is we take our balloon. We want to stretch it out a little bit here. Stretch out the mouth of the balloon. We're going to take it and we're going to put it right on top the mouth of the bottle. Down like that. Okay, now we found out over the years when we do this experiment that if we don't tape it, that the balloon's going to pop off there, and we don't want it to pop off. Okay, so we're going to take our tape. I'm just going to go like this right here, nice and tight, all the way around. Okay. We don't want that balloon to come off. We want it to stay right where it is. We're going to have to take this tape off when we're done, so we're going to take the end of it, and we're going to fold it back like that so we can find the end of it easier. Okay, so we're going to let this sit here, and we're going to take, our instructions say take readings, measure the diameter of the balloon every 5 minutes. We're going to use a timer, a clock, or your cell phone or something. We're going to come back every 5 minutes and check our little project here, see where we're going. Okay, this is our first check after 5 minutes. You notice the balloon, not very big here. It's got a little bit of gas in it, but not much. So we're going to take our going to measure the width of the balloon. We're going to say 4.2 centimeters, okay? You need to write that down, 4.2 centimeters. That's the first check. Okay, we're back for our 10-minute check. Okay, so we have 5 minutes in between. Now we're looking at about 5.4. So we need to write that down. And our balloon's got a little bit of a life to it there, okay? So our first, our 10-minute check, the balloon was 5.4 centimeters, and the first one was 3.2. Okay, so we're going to come back in 5 more minutes and see what's happened to our little balloon. Okay, we're back. This is minute 15, our 15-minute check. So we're going to put our little ruler here and make sure we keep it straight on this side. And our little balloon is out to 6.4. So we're going to write down 6.4 in 15 minutes. And we're going to come back in 5 minutes. Okay, class, we're back. This is minute number 20. And look, our little balloon's getting a lot bigger, huh? And we're going to take our measurement on our little balloon. We're going to put a pencil like this on this side so we can look on the other side. It looks like 7.8. It's getting pretty big. 7.8 centimeters. Okay, we're back for minute number 25. And look at our little balloon here. It's going crazy on us, all right? It's out to 9 centimeters, so it's 9.0. Minute 25, 9.0. Okay, we're back. This is minute number 30. Going to take our reading. Going to take our pencil, put it here like that. We're out to about 9.6 centimeters. So 30 minutes, 9.6. Wonder how big it's going to get. Okay, we're back for reading for minute number 35. And put this here like that on the side, take our finger and go like that. It's kind of slowed down. It looks like we're still about 9.6. Put down 9.6. Okay, class, we're back for minute number 50, a reading at 50 minutes. I'm going to take our balloon, we're going to put a pencil like this, and it looks like it's out to about 10.6. Now, you need to be thinking about what's in the balloon. Something's in there. Obviously, it's coming from down here, right? Be thinking about what's in the balloon. Okay, we're back for reading on minute 55. Our balloon's getting bigger, huh? So we're going to take our pencil, we're going to put it like this, and we're going to look at it over on this side. It's out to 12.0. So minute 55 is 12. Okay, guys, we're back for minute number 60. 1 hour we've been doing this lab here. So we're going to take our little pencil, we're going to put it right there. Going to look on the other side, it's up to 13. Took a big jump, 13.0 centimeters. So our little balloon's getting really big here. Okay, I wonder how big this little balloon's going to. I got a big hand. That balloon's almost as big as my hand now. What's inside of the balloon? Okay, we are back for minute number 65. See what we got going here. Looks like we're out to about 13.8. So minute 65, 13.8. Our little balloon's getting bigger. What's inside the balloon? Okay, we're back for minute number 70, 1 hour and 10 minutes. I'm going to take our pencil, put it like this. Looks like we're about 13.5. Okay, so minute number 70, 13.5. Okay, we're back for minute number 75. Here's our balloon right there. And we're still about 13.5. It did not change. Okay, we're back for minute number 80. Our check at 80 minutes. Let's see what we got. Our little balloon got a little bit bigger, I think. Yes, it did. We're out at 14.2. Okay, so minute 80, 14.2 centimeters. What's inside the balloon? That's the question of the day. Okay, we're back for our check at minute number 85. And our little balloon looks like it's getting bigger yet. So 85, we're way out here to 14.5. So minute 85, 14.5. Okay, we're back for our reading on minute number 90. Our little balloon is getting even bigger. Take our pencil, put it right here. Look on the other side. It looks like we're at 14.6. It grew just a little bit. So what is inside the balloon? Something down here. We got a few bubbles down here in the bottom. So maybe those bubbles are an indication of why this balloon is getting bigger. Anyway, we got 2 more times to check. Okay, we're back for minute number 95. Our balloon is bigger than it was. We're going to measure. It's going to go all the way out to there. It's 14.8. Getting a little bit bigger. My goodness, what's in that balloon? What could possibly make it get that big? It's got to be something coming down from here, right? So what's in that balloon? Okay, we're back for our last check at 100 minutes with our balloon here. I'm going to take this pencil, put it right there. It looks like it's pretty close to 15 centimeters, 15.0 centimeters. So our balloon is expanded up to 15 centimeters. That's about that much right there. That's a pretty good expansion there. So that balloon's got a lot of something in it. I wonder what it is. Be thinking about evidences of a chemical reaction taking place. We talked about that earlier in the year. Okay, we need to go on to the next step of our lab here, okay? Our instructions say after we've done all the calculating that we need to take our little balloon off and weigh it again. Now, that's going to be tricky because we want to weigh what is inside the balloon. So to do that, we're going to pinch this off like this. Just going to twist it like that. Hold it real tight. And remember, we put that little tab, we folded it back so that we could get this tape off because we had to weigh the tape with it before, if you remember right. Come on now. Come on, come on, come on, come on. All right, so I'm going to take our little balloon, slide. Okay, we got it off. So we can set this aside. We don't need that anymore. So we got our little balloon and it's full of something. And we're going to weigh it and we're going to weigh the tape with it, okay? So let's just get ready for that. All right, this is going to be a little tricky part of the lab here. We're going to take our balloon, I'm going to tie it in a knot so whatever's inside of there can't come out. We don't want that to get away from us. That's what we need for another part of this lab. We want that stuff in there. Okay, we got that. There, good. All right, so we're going to take our tape. We're going to put it on our balloon like that. That's going to help it stay on the scale. We're going to weigh it. Does anyone remember what it weighed before we started? It weighed 3.17. Now it weighs 4.2. 4.24. Okay, that is a gain of 1.07 grams. Okay, class. So we weighed our balloon. We re-weighed our balloon. We got our little balloon right here. We know it gained a gram, 1.07 grams. So here's the test for carbon dioxide. We suspect that this balloon has carbon dioxide in it. So we've got a little candle going here. What we're going to do is we're going to take our balloon and we're just going to, we had it rolled up there, we're just going to take, and you should know, carbon dioxide puts fire out, right? They make fire extinguishers that have carbon dioxide in it. We're just going to take carbon dioxide and let it down on top of the candle. We're going to see what happens. There it goes, went out. So, try it again. Take our carbon dioxide, and we've got a lot of it left here, okay? And we're just going to take it and let it go out on our candle. Put the candle out. Let's do it again. It's always fun to, you know, have fire in the lab. So let me get another match. There we go. Okay, one last time. We got enough for one more little trial here. So here we go. There you go. Now, do not do something silly or foolish like breathe the carbon dioxide, all right? Not good for you. Okay. Very good. Experiment we did, we have our data collected on our sheet here. We recorded that in our lab book. So we need to talk about what we learned by doing this lab, okay? So the yeast in the bottle that we had obviously gave off carbon dioxide. And we need to talk about cellular respiration a little bit. But we have some questions here. Did the weight of the balloon change? Yes, it did. Why? Okay. Carbon dioxide's a gas, so why would it make the balloon change weight? Okay, consider the following chemical equation. C6H12O6 plus 6O2 yields 6CO2 plus 6H2O plus energy released. What are the products of that reaction? What number 3 says? What evidences are there that a chemical reaction took place? You have to remember, we've talked about evidences of chemical reactions, and what are some evidences that we could observe here that chemical reactions were taking place? Okay. What kind of respiration does the yeast carry out? We're going to graph our data. We'll do that next. And at what time was the production of carbon dioxide the greatest? Okay. So we got a little graph here. So next thing we do is we're going to do making a graph of our data. So let's pause right here. Okay, let's talk about the graph. Okay. It says put your data, the x-axis is the time. So this is going to be the time down here, or the minutes. Okay, that's what we're going to put down there. The y-axis, it says to put the size of the balloon. Okay, so the time went from 0 to 100 minutes. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 squares across. So we have to put it, we're going to need 1, 2, 3, 4, 5, 6, 7, 8, 9. Going to need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we're going to need 19 lines. So we're going to have one left over on the end. So the first one, we're going to go by minutes of 5, right? So we got 5. I'm not going to put 5. I'm going to go like this. 10, okay? 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Right there. So we get the minutes in like that, all right? Okay. Okay, so the first, on our data table here, you guys wrote this down, our data, first 5 minutes, the diameter of the balloon was 3.2. Okay, so if we go up the size here, we have to be able to, it has to be able, the highest number we had was 15 centimeters. So we go up the side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we just go by ones. That'd be easy. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? So I just went by 5, 1, 2, 3, 4, 5. You don't have to mark every one. You can if you want to. Kind of jumble stuff up a little bit if you do that. Okay, so our first reading at 5 minutes was 3.2. So we go 1, 2, 3.2 right there, okay? 10 minutes, it was 5.4. So here's 5, and there's 6. 5.4 would be right there, okay? At 15 minutes, it was 6.4. So here's 6.4 right there. 20 minutes, it was 7.8. So 20 minutes, there's 6, 7.8, almost 8 right there. At 25 minutes, it was 9. Wow, that big jump. 25 minutes was 9. 30 minutes, 9.6. A little over halfway. 35 minutes, it was 9.6. It stayed the same. 40 minutes, it was 10.1. So here's 10. It went just a little bit above 10. 45 minutes, it was 10 point. I didn't put 45 minutes on our data sheet here. My bad. So we got to go to 50 minutes. It was 10.6. 50 minutes right here. 10.6. I'll have to make that correction on the instructions. 55 minutes, it was 12. So here's 55 minutes. There's 11, 12. 60 minutes, it was 13. Right there. 65 minutes, it was 13.2. 70 minutes, 13.5. 75 minutes, it was 13.5. I thought it was going to level out and stay there. 80 minutes, it went up to 14.2. 85 minutes, it went up to 14.5. 90 minutes, it went up to 14.6, almost the same thing. 95 minutes, 14.8. And 100 minutes, it was exactly 15. Okay? So we just got to connect our dots, right? So here we go. Try to pick a color that would show up good for you. So we just keep going like this. Did it go back down? 50 minutes, I got 40, it was 10.5, 10.6. I got that in the wrong spot. 10.6 should be right up there, okay?
I finished yours with.
Okay, pause that. Okay, let's see, we're on 55 minutes, 55, it was 12, right to there. And then we go up to 60 minutes. Then we go up to 65. Like you got like a little straight line there. And there you go. Okay. So you should be able to see that graph there pretty well, huh? So one of the questions is, when was the production of the carbon dioxide the greatest? Well, obviously right there, right? Obviously the greatest was right there. We had a big bump right here, then it kind of leveled out a little bit, bumped back up, and then it went back up like that. Sometimes we do this lab, we'll get a peak and it will go back down. Okay, so that would have been interesting to see if it went back up and if it went up and then back down. But there you go. There's our graph of the production of carbon dioxide from the yeast. This is a very interesting lab, I think. Many of the labs have procedures to follow that if you don't follow them correctly, things just don't go well for you. And so one of the tricks of doing a lab and getting something out of it is following procedure. Let's see, so what do we got that's new in this lab? We got this thing right here. Anybody know what this is called right here? That's called an Erlenmeyer flask. Probably because somebody named Erlenmeyer made the first one, okay? We have our electronic scale that we used. And we learned how to measure with our electronic scale. We learned what the word tare means, T-A-R-E. So this has been an interesting lab to do with you. We'll check back with you and go over it in class. And it's been fun doing it with you. Take care. We'll see you on the other side. This is Keith Smith, science teacher extraordinaire, helping out with understanding cellular respiration.
No strings tying you to me. I'm happy in your company with no emotion, 'cause my love deserves to be free.
So, our balloon gained weight. So whatever is inside of our balloon, gosh.
It's just my turn, but we can still have fun.
I hate it when that happens.
You told me you don't really do commitment, trust me. Consider your message received.